According to the theory of evolution, the origin and development of the universe and all its systems can be explained solely on the basis of time, chance, and continuing processes. All living things have arisen from a single-celled organism. A second and opposing worldview is the concept of creation. According to the theory of creation, everything in the universe has come into being through the design, purpose, and deliberate acts of a supernatural creator. That means this creator created the universe, the earth, and all life on earth, including all types of plants and animals, as well as humans. On today's edition of Origins, you'll be amazed by the fascinating facts of the seeing eye.
Hello, my friends. Welcome to Origins. My name is Donn Chapman, and I'm your host. Origins is a forum where we take the evidence of science and we use it to validate the truth of creation. We do that by finding guests, either scientists or Christian apologists, who take their research and their evidence and come and share it with us to validate creation. We have with us today an incredible guest. I think it's one of the great honors of our Origins show to have with us today Dr. David Menton. Dr. Menton, can I just tell you what a privilege it is to have you here?
Oh, thank you, Don. It's my pleasure.
For 34 years, you taught at Washington University in St. Louis, Missouri, in the School of Medicine there.
Well, at the medical school, I taught in the first year of the medical school. All medical students take the sort of basic science or preclinical year. And one of the very first courses that the student is introduced to is gross anatomy, which is the dissection of the human body. And I taught that for several years. But my primary responsibility was to teach how the body looks through the light and electron microscope, sort of microscopic anatomy. We sometimes refer to that under the Greek name histology.
Histology.
Right. That means to look at the tissues of the body.
Now, you're a very humble man, but you are one of the world's experts in that field. Isn't that true?
You might say I sort of wrote the book on it to some degree, and that I was the editor consultant for histology for Stedman's Medical Dictionary for 5 editions up until the last edition.
And so, when it came to what words meant in the field of histology, you wrote the book.
Yeah, it was kind of a sobering experience. I could go in and decide. Of course, I had to be as accurate as possible.
Today we're going to talk about the seeing eye. And let's begin with the authority of Scripture. What does the Word of God have to say about the eye?
Well, you know, it's interesting, Don, that the Bible doesn't tell us really anything about the spleen.
No.
It doesn't tell us anything about the thyroid or the parathyroid or oxyntic cells. It's not meant to be a book of science or anatomy, but when it touches on anatomy, we can trust it there too. And the Bible does have a lot to say about the eye. If you do a computer search, you'll see eye comes up quite a bit. And here's a verse that we're looking at here now that deals with the pupil of the eye. I'll bet you've heard that expression, "You are the apple of my eye."
Yes, sir.
That expression actually comes from the Bible.
Uh-huh.
And the ancient Hebrews, they called the pupil, that little black spot right in the middle of the eye. You can see it right here.
Okay.
Oh, we need to get a color on that.
Right in the
Right
middle.
in there.
Yes.
That's the pupil.
Okay.
And you're looking through a hole there into the interior of the eye. And the Israelites called that the apple, because I guess it was round, it looked like an apple. And that expression, apple of the eye, then refers to the pupil. But in the Psalms, Psalm chapter 17, verse 8, for example, we read, "Keep me as the apple of your eye," and the word keep there really means protect. "Protect me as the apple of your eye, hide me in the shadow of your wings." This is a prayer of the psalmist to God. And what that really means is that they knew that if you touched the eye right over the pupil on the cornea, that you'd blink and recoil. And that reflex that causes that to happen is so powerful. It's one of the last reflexes to be lost when we die. And emergency technicians will sometimes touch the cornea right over the pupil. And if there's no blink, the person's probably gone. And the Lord wanted us to know that His protection for us is at that level, just reflexive, right to the death. The human eye is so complicated that it defies our ability to actually explain it. If I were to pick one person who is sort of one of the most visible authorities in the eye, I think I would pick Dr. Stuart Duke Elder, who's an Englishman, a physician, and has written a set of books, or edited a set of books, that are really an encyclopedia on the eye, beginning with its evolution, then its anatomy, its physiology, its pathology, its surgery, right on through. And in the first volume of that series, called The Eye and Evolution, Dr. Duke Elder said, "It would seem, therefore, that despite the considerable amount of thought expended on the question of the emergence of the vertebrate eye, with its inverted or upside-down retina, of neural origin and its elaborate dioptric mechanism derived from the surface ectoderm, it is a problem as yet unsolved."
Explain that to me. The vertebrae, what's he saying to us there?
Well, he's saying
What's the problem?
that we haven't been able to come up with an explanation for the origin of the eye. For example, he goes on to say that indeed, appearing as it does, the eye, fully formed in the most primitive species that exist today, and in the absence of any transitional forms in the fossil record that you might see.
So in the most basic primitive forms, you still have these fully developed eyeballs.
All the different kinds of organisms, primitive, advanced, whatever as we might call it, eyes are always complicated. And he goes on to say that he finds little likelihood of finding a satisfactory explanation to this solution.
That's amazing.
So he says we really don't know anything about the eye, and he really doesn't think we're going to ever know anything about the eye. And the thing that's really intriguing is that this is an 847-page book, Don. And I would think that if I were studying the origin of the eye and I'd come to the conclusion that we know nothing and that we never will know anything about it, I could have gotten that point across in maybe 600-700 pages. I wouldn't have needed
You don't think that actually
847.
You wouldn't have needed the last 150 pages. Well, tell me, what do trilobites have to do with us learning about the human eye?
Well, that's an interesting story. Let me run up here to the
Please do go. Go up to the screen there and show us what you
teleprompter,
got.
whatever this is, and
Yeah.
we'll talk about it a little bit. These are trilobites. They look like roly-polies. If you've ever seen a roly-poly, you know that they are kind of segmented creatures. They lived in the ocean. Presumably, according to evolutionists, became extinct a long time ago. And the interesting thing is that they have many different types of eyes, at least 5 fundamentally different types of eyes, and some of the trilobites didn't have eyes at all. The thing that's intriguing is that there are 2 species of trilobites in which their sort of glass lens has been studied. They find out these lenses didn't need to focus. They were in focus from just a small fraction of an inch out to infinity without having to change the position of the lens. And not only that, but this is amazing. The lens is a compound lens in the sense that it's made up of more than one kind of glass that's been ground and put together, you might say, cemented to make a doublet. And this particular trilobite here has a lens that was discovered by Descartes back in the 1600s and was believed to be the most perfect lens that could be designed at the time. And this particular lens here, found in another trilobite, again a doublet put together, is identical essentially to a lens designed by another great physicist by the name of Huygens at about the same time. So here we have trilobites running around with highly corrected lenses that are a little hard to explain. Well, let's talk about the human eye. We've talked about trilobites, and we'll go on to look at that. People usually don't understand that the eye is really part of the brain.
Oh,
you look at somebody's eye, you're actually checking the brain out a bit here. And the eye comes from a pouch that comes out from the brain. There's a little ball, and it gets pushed in like a basketball here that got pushed in. And that's all part of the brain. The lens of the eye and the cornea, the window in the front, actually buds off from the surface, basically skin. And these two structures, one will form the retina of the eye, and the other part will form the lens and the cornea. So two different origins there. This is a kind of a picture of what 1/4 of the eye would look like. And here is the lens the way it has developed in an adult, be the left eye looking up. And the lens is kind of suspended by little strings. They're sort of hollow tubes. And the lens is clear as glass, but it's flexible, like a rubber ball. Huh. And the tension of the filaments at the edge can either cause that lens to become flattened or to round up. There are cells that grow on the surface of the lens. These cells move around to the edge, and when they get to the edge, they turn into the lens. And when they turn into the lens, they become elongated, like pulling an antenna out of a car. And it actually goes from up here all the way around to down here, each lens. Let's take a look at those lenses. We'll magnify that edge of the lens.
You're just taking that little edge and magnifying it up again.
Right. In the light microscope, we're just going to look at that left edge there, right where you see the box.
Okay.
And over here we can see it. Cells are like little boxcars coming down to the edge, turning into the lens, at which time they become elongated. Huh. And when they become elongated, they form what we call lens prisms. Let's look at those lens prisms in the scanning electron microscope. Sort of looks like a lumber yard.
It really does. Piles of stuff there.
Individual cells, each of these board-like structures is a cell. Having a little trouble seeing that there, we can bring it up a little higher power. And notice that these boards are interlocked in perfect register by a little peg-in socket.
Yeah.
Thousands and thousands per cell interlocking it. The cell is full of a protein called crystalline, which is very clear and gives the lens its clear property. Just think of this whole mechanism. These cells are dead, basically, in our lens, and they're soft. But I don't know about you, Don, but you get to be my age, and the lens becomes harder.
Yes.
And as it becomes harder, we can't focus anymore. So if I take my glasses off, here's focus for me.
Yeah.
Further away, in closer, out of focus. I have to have special progressive lenses.
Now my focus got slightly past the length of my arm. That's where mine is
right?
now. Yeah.
And I believe the Lord made us to have a lens that would focus and be functional for our whole lifetime. But since the fall into sin, our lenses are just one of the things in our bodies
It's affected by the fall.
that can become defective with time. And it changes in color. It's kind of yellow. It can get opacities in there that we call cataract.
Yes.
It can become hard and not focus. But in the original conception, it clearly is a nice rubbery, flexible lens that can change focus. It's just amazing that we are put together in a way that has been described as fearfully and wonderfully made, and that is certainly the case here.
You know, we've got to take a break. You stay with us, and in just a minute, Dr. Menton's going to come back, and he's going to really reinforce what we're learning about how the intricacy of the eye teaches us the marvel of our Creator.
Creation versus evolution. You weigh the evidence. The human eye, a chemical speedster. For us to see, chemical and electrical reactions must take place in the proper sequence. The fastest photographic film requires the camera lens to remain open for 1/10,000th of a second. Biologists tell us that the eye's photochemistry is so fast that the first reaction takes place in 1/5 of a second. This is 500,000 times faster than our best film capabilities. Darwin himself admitted that the human eye seemed to defy his theory of evolution.
Today's guest on Origins, anatomist Dr. David Menton, is a speaker for Answers in Genesis. Audiences enjoy his well-illustrated presentations on a variety of fascinating topics. Many of these lectures are available on DVD. If you are interested in the subject of creation, you'll definitely want these for your own. Orders are being taken at 800-778-3390. You can also write to Answers in Genesis, P.O. Box 510, Hebron, Kentucky, 41048. Or visit the website at www.answersingenesis.org.
We're back from our break. I'm here with Dr. David Menton, and we're talking about the seeing eye and the marvel and the complexity of how the eye is made. What is it about the eye that makes the evolutionists say that it's poorly designed or poorly engineered? It seems to work so beautifully to me, I can't understand what they're complaining about. Help me understand.
Really, the feature that they touch on as being evidence of poor construction is the retina.
Okay.
The retina is down here in this area, and we could think of it as being like the film in a camera.
Okay.
And the light comes through and hits this film. Now, I don't know if you ever worked with one of these cameras that shoot sheet film, but if you put the film in upside down, like the old view cameras, so the film is in backwards, you get no pictures.
Yeah.
So what the evolutionist is basically saying here is that the film in the camera, which is the retina, the light-sensitive part of an eye, a little thin sheet, thinner than tissue paper, that it's in there upside down. And what exactly do they mean by being upside down? Let's look at one little part of the retina. We'll take a section about where you see that box there and magnify that. And this is a picture in the microscope of a cross-section of the retina. So it's very thin, but it looks thick here after we magnify it several hundred times. And we notice that the retina has a number of cells in it. These are ganglion cells from the brain. So the eye is really part of the brain. Huh. It buds off the brain, and here are ganglion cells that are the types of cells we would see in the brain. The light-sensitive cells that are actually responding to the light comes down from the top like this and has to go all the way down to here before it hits the light-sensitive part of the retina. These are the photoreceptors. There's about 120 million of these in the eye, and instead of facing up, they face down, away from the light. Doesn't seem like the right way to make it. You know, evolutionists have told us that without evolution, nothing in biology really makes any sense. Well, here's a case where with evolution, this piece of biology is not going to make sense. And what they've argued is the retina really ought to be the other way around, to take these light-sensitive cells and bring them up to the surface here. Now, that's the way it is in an octopus.
Oh.
They have the retina right side up. But all vertebrates, animals with bones, have it upside down. So take an eagle. The retina would be upside down. Okay. Well, does an eagle see pretty well? After all, we use the expression eagle-eyed.
They always catch more fish than I do.
That's right. And you know why they catch more fish now?
They see better.
It's been said that when they're up in a tree along the river, they can see a fish just under the surface of the water up to a mile away.
Wow.
I got a feeling if you put an octopus up in the tree, he wouldn't see anything.
I got a feeling.
Of course, maybe the eagle wouldn't be that good underwater. So
yeah.
I think each one is optimally designed for its own purpose. Why is this a bad idea to bring these cells up here? Well, it turns out that, first of all, the retina works beautifully just the way it is. Our retina is sensitive to a single photon of light. That's the smallest quantity of light we have.
Wow.
In addition to that, the resolution of the retina, in other words, the sharpness of the picture, is better than the lens and the cornea can produce. So we say it's a refraction-limited system. It's a system limited by its optics, not by its film.
Wow.
More importantly, these photoreceptors have to be very, very close to the blood supply, and the blood vessels are down here, and it's the most richly supplied system in the body in terms of blood. You could think of it as like a solid lake of blood down here, and if you brought these photoreceptors to the top, you'd have to put all of this blood on the top. You couldn't see through it. So it's really pretty optimum, just the way it's put together. You know, there really is a sandwich of blood vessels. We have a layer of blood vessels up here that you see here in the picture, and then we have this really elaborate supply of blood down here, and here's the retina in between. But the blood vessels that are on top of the retina are nowhere near as extensive as the ones that are on the bottom. And we do have to look through those. And that's rather like looking through a plate of spaghetti.
Yeah.
You ever wonder when the ophthalmologist looks in your eye with the little scope,
right,
what he's seeing in there? Possibly old movies or something? This is the picture through the ophthalmoscope. And these are the retinal vessels that are on top of the retina. which are not as numerous as the ones underneath, and we have to filter those out so we don't see them. Otherwise, they'd be in our visual field. And the mechanism of filtering those out is just amazing. It turns out the eyeball, because of its muscles, is caused to tremor at a high frequency. And this tremoring causes the retina to move like so. Now, the blood vessels in the retina move with the retina as the eyeball tremors. The brain has a little rule. It says if it doesn't move, ignore it. So the shadow of the retinal blood vessels that you see here doesn't move as the eye moves, but the movement of the eye causes everything we look at to be moving. So that if I'm looking at a tree, the tree is moving on my retina. And thus we see the tree, but we don't see the blood vessels because they're moving with the retina. Now, what about the muscles that move the eye? There is a muscle on top of the eyeball and one on the bottom, and of course that moves the eyeball up and down. There's one towards the nose and one away from the nose. That moves it left and right, like a horse's head on a... And then, oh, my favorite muscles. There are two more, so not just four in each eyeball. There's one on the top, one on the bottom, and they go crossways. And when these muscles contract, our eyeballs actually do this. They turn left and right. Now, why on earth do we have muscles that do that? This is so neat. It turns out that when we walk, we kind of tilt from side to side like this. And it's very important that our horizon not be going. We get dizzy, fall down.
Yeah.
And so as our head tilts from side to side, the eyeballs rotate to keep the horizon level. And this muscle, by the way, is just spectacular. It has to go through a pulley, a lubricated pulley, in order to contract and pull around the corners. The muscle goes right down into the orbit of the eye, comes out to the edge, and goes across. So most remarkable.
That is absolutely incredible, the intricacy of that.
Muscles of our eyes. Well, probably a good place to kind of bring things to a conclusion here is the eyelid. The eyelid distributes water and fluids over the surface of our eye to clean the eye, much like window wipers would clean the window of a house. The fluid flows from out here at the edge of our eye across to our nose. And when it gets to the nose, there are two little holes. I think you can see them here. There's one little hole here.
Yeah.
And there's one little hole here. And these two little holes, called puncta, suck the water off the eye to keep the flow going across the eye. And the pH of this water, and there's special proteins to kill bacteria and what have you in the water, and the level in your window washers are automatically maintained. Would it be terrible if we had to go check the window washers in our eye? And when you get the fluid to come across the eye like this, just keeps coming across, you have a little oil dam around the edge that keeps the fluid from breaking over the edge, so it forms a surface. In fact, it's a water layer on our eye that forms the optical surface. It's much smoother than if you just had the cornea. That's kind of rough. So this film of water is optically important. But of course, as we tear up, the layer can get quite thick. And if the layer gets thick, we get bleary-eyed, don't we? And so we have a system that is constantly removing the water, trying to stay ahead of it. Here's the tear gland here. And over here, we have the little pumps that pump the water off the eye. The water comes off and goes into this little duct system down into the nose. That's why you get the sniffles when you cry.
Into the nose, yeah.
If the tear fluid builds up too much, the tear fluid can finally break over this oil dam and
we cry.
Come down the cheek in the form of tears. And, you know, I think that's a good note to conclude on, because the Bible even has something to tell us about tears. It tells us, for example, in Revelation chapter 21, verse 4, "And God shall wipe away all tears from their eyes, and there shall be no more death, neither sorrow nor crying, neither shall there be any more pain, for the former things have passed away."
Dr. Menton, you've done us a great service today, and it's great
thank
to
you.
have you with us, seeing the intricacy of the eye and the marvel that it makes. And friends, I just want to thank you for being with us. You know, our bodies are so incredibly made that they had to have a maker. You know, if you have questions about something that Dr. Menton has said, or if you have suggestions for us here at Origins, write to me at Origins, Cornerstone Television, Wall, PA, 15148. Or you can get on the internet and find us at originstv.org, and there we'll find experts that will answer any questions you have to confirm the truth of creation. You know, I just want to remind you that it's God's view that He created you, and that should be your worldview too. So until next time, it's been great having you with us on Origins, and we'll look for you again. God bless you.
Thank you for watching this edition of Origins. If you'd like a copy of the PowerPoint information presented today, you can download a PDF file of program number 650 from our website at www.originstv.org. Or for a DVD of this series, send a $12 donation to cover shipping and handling, and write to Origins program number 650, Cornerstone Television, Wall, Pennsylvania 15148.
Origins is made possible by the faithful prayers and the financial support of you, our Cornerstone Television family.